This is your video for week 12. In this one, we're going to do a review for the Unit 3 exam. The first page of your week 12 notes has important information about the exam. I'll let you read through this yourself. At the bottom of this page, there's a list of identities and some other information that you need to have memorized for the exam. This is in addition to other information that you've already memorized for previous exams. For the rest of this video, we're going to go through some example problems. We're going to start with problems where we're using some of those identities. The first one is that if tangent of theta is equal to 1/2 and theta is in quadrant 3, we're going to try to find the exact values for the remaining 5 trig functions of theta. The first thing we can think about here is that in quadrant 3, only tangent and cotangent are positive. That means the rest of our trig functions will all be negative. The first thing we can do here, since we just have the value for tangent, is we can use one of our Pythagorean identities. We're going to use the one that has tangent in it, and that would be tangent squared theta plus 1 equals secant squared theta. We can use this and substitute in the value that we know for tangent theta. We can solve this for secant theta, and that will get started on finding some of our other function values. So if tangent theta is 1/2, we're going to take that value and square it. This would give us 1/4 plus 1, which would be 5/4. Now we know the value for secant squared. We want to find just secant. And we know from up here that only tangent and cotangent are positive. That means secant is going to be negative. We're going to take the square root of this and use the negative value. That would give us negative square root of 5/2, which is our value for secant of theta. Since we have that, we can use one of our reciprocal identities, flip this over, and that will give us the value for cosine of theta. We have these two. We know tangent. We can also find cotangent very easily just by taking our value for tangent and flipping it over. That would be 2/1, or just 2. The two that we have left to find are sine and cosecant. There are a variety of different ways we could get either one of those two. I'm just going to use the first Pythagorean identity since we know the value for cosine. I'm going to use this identity, substitute in the value that I have for cosine, and then solve for sine. I'm taking the value I have for cosine and squaring it. That's going to give me 4/5. I'm going to subtract 4/5 from both sides, and that will give me 1/5 on the right side. Now I need to take the square root of both sides. We already know that all of the functions except for tangent and cotangent will be negative. That means I'm going to take the negative square root here, and this will simplify to just -1 over the square root of 5. So now I have the value for secant, the value for cosine, the value for cotangent, and the value for sine. The only one I don't have is cosecant. I can just take my value for sine and flip that over. That would give me negative square root of 5. For the next problem, I want to find the exact value of secant if sine of theta is 6/7 and cosine of theta is greater than 0. If cosine is greater than 0, that means that also secant of theta will be greater than 0. Since I have the value for sine, I could use my first Pythagorean identity and find cosine, and then I could use my reciprocal identity from there to find secant. I'm going back to this identity again. I'm going to put in my value that I know for sine and square that. That would give me 36/49 plus cosine squared theta equals 1. Then I want to subtract this from both sides. If I take 1 minus 36/49, that's going to give me 13 over 49. That's my value of cosine squared. Now I want to take the square root of each side, and I know that my cosine is going to be positive, so I'm going to take the positive square root of this value. That would give me the square root of 13, and then the square root of 49 is 7. There's my value for cosine. To get secant, all I have to do is flip this over. For the next question, I want to find a way to write the cosine of pi over 2 minus 2 theta as a function just of theta. In this one, because I've got two angles in here that are subtracted, I'm going to use my difference identity for cosine. And that one looks like this. The cosine of a minus b is the cosine of a times the cosine of b plus the sine of a times the sine of b. My a is going to be the pi over 2, and my b is going to be 2 theta. This would be the cosine of pi over 2 times the cosine of 2 theta plus the sine of pi over 2 times the sine of 2 theta. Now here where I have an angle measure, I can put in the values. The cosine of pi over 2 is 0. The sine of pi over 2 is 1. So this whole term would be 0. And here I would have 1 times the sine of 2 theta. So that whole thing is going to simplify to just the sine of 2 theta. Then if I want to write this just as a function of theta, I can use my double angle identity, which would make this 2 sine theta cosine theta. Now I have this simplified to where it's just a function of theta.
Let's look at problem number 4. In this, we're supposed to find an exact value for the sine of 157.5 degrees. Now this obviously isn't one of our special angles. We want to think about whether we can use one of our sum or difference identities or one of the half angle or double angle identities to get 157.5 degrees. Now since this has a 0.5, it's likely to be half of one of our special angles. Let's see what happens when we multiply this by 2. When we do that, we get 315 degrees. And that is one of our special angles. That is 360 degrees minus 45 degrees. So that means it's a fourth quadrant angle with a reference angle of 45 degrees. What we want to use is the identity for the sine of a over 2. And that is plus or minus the square root of 1 minus the cosine of a over 2. That's the identity that we're using. The angle that we're putting in here for the a is going to be the 315 degrees, so that when we divide it by 2, we get this number. That means that over here, our a is 315 degrees. Now when we do this with the plus or minus, we can just look at the angle we have here. This angle would be in the second quadrant. In the second quadrant, sine is positive, so here we're going to have the positive square root. Then we need to find the value for the cosine of 315 degrees. Since this has a reference angle of 45 degrees, the cosine would be the square root of 2 over 2. In the fourth quadrant, cosine is positive. That means that this value would be the square root of 2 over 2. And then if we simplify this, we can get a common denominator here, put this together. That's going to give us 2 minus the square root of 2 all over 4. If we wanted to, we could pull this out of the square root, and that would give us the square root of 2 minus the square root of 2 all over 2. Now let's look at this one. This time we probably have quite a few different ways that we could find this value. Let's think about this as a sum or difference of some of our special angles. 19 pi over 12, we don't talk about the family of angles for pi over 12. What we could try to do is separate this into two different angles either added or subtracted where they would reduce to one of our special angles. For example, 19 pi over 12, we could write that as 16 pi over 12 plus 3 pi over 12. Both of these will reduce. This would reduce to 4 pi over 3, and this would reduce to pi over 4. Those are both in our special angle families. That would work. Or we could do something like 10 pi over 12 plus 9 pi over 12. Again, these would both reduce. This would reduce to 5 pi over 6. This would reduce to 3 pi over 4. And both of those are in our families of special angles. There are a couple other ways that we could do this. Let's just take one of these and use it. So let's take this one and reduce both of these. This would be 4 pi over 3, and this would be pi over 4. Now what we're going to do is use our addition identity for cosine. We have the cosine of 4 pi over 3 plus pi over 4. That would equal the cosine of 4 pi over 3 times the cosine of pi over 4 minus the sine of 4 pi over 3 times the sine of pi over 4. After that, we're just plugging in values for all of these. 4 pi over 3 is in the third quadrant, so both the sine and the cosine are going to be negative. Pi over 4 is in the first quadrant, so both the sine and the cosine are going to be positive. The cosine of pi over 3 is 1/2, so this would be negative 1/2. This would be the square root of 2 over 2. The sine of pi over 3 is the square root of 3 over 2, so this would be the negative square root of 3 over 2. And the sine of pi over 4 is the square root of 2 over 2. After that, it would just be a matter of simplifying this. This would be the negative square root of 2 over 4. Here we've got two negatives. That turns into a plus, and then we have the square root of 6 over 4. So the most that we could simplify this is by writing it together. We'd have the negative square root of 2 plus the square root of 6 all over 4.